Hi. I'm trying this thing. I'm not sure if it works. Yeah, it does. Okay, so I'm Soledad Penades. Thanks for the effort. I'm an apps engineer at Mozilla. I joined quite recently. You can find me as Super Sole in Twitter. Sole was already taken. We also use IRC in Mozilla, which is pretty cool. So if you have any question about apps, you can join the apps channel in irc.mozilla.org, and you can probably find me in London time because I work in London, so I'm severely jet lagged. If I do or say something inappropriate, I apologize in advance because I just slept 1 hour today, so I'm like destroyed. And we also have this history of making stupid, silly things that use web technologies like this thing. It doesn't have anything to do with web audio web components, but it's super funny. And I like to introduce it because it's kind of the funny things about being in Mozilla. And I hope it works. Hi. So the way it works is I did the animation capture thing, and it's like capturing my face when I say hi. And it will hopefully send it, and it just starts looping. And people are addicted to this thing. It's pretty amazing. I'm like, I know people who are like all the time there. Yeah, I was kind of, and it's all open source. So if you want to improve something, hi. See, it's addictive. Okay. So yeah, I'm just going to close it because you can get any work done with this thing running. So apart from that thing, I'm totally into music. I was counting. I thought I had 100, but I've composed 150 plus songs. Apart from things that I would never say I did it. And I've been writing audio toys because it's fine to write songs, but it's even funnier to write your own instruments. I've been trying to do that thing for the last 5 years. I'll just go through the thing. So the first synthesizer I built was called Soledad, which is tiny noise in Catalan. And I like to use like our own languages for naming things because it's easier to get a good position in Google as well. So it was built in pure C. And it didn't have any GUI. The GUI was me. If I had to change any parameter, I had to recompile things manually. And it was kind of, like I was trying to find some terrible part. And it didn't have any terrible part because it was pretty small. But it was very C, like these things. And it was C, so it didn't have any class. So I think it was like, you had to take the instance and pass it there. And it was very non-encapsulated at all, and you had to do these kind of things like casting, and it's like this. So I was like, oh, well, that's fine. I did that thing, and I built it with SDL, and it was okay, but, well, so 2010, I was like, I gotta improve this thing. So I did version 2, and it was, I don't know about virtual instruments thing. I don't know what the whole thing is, but it's like, You can build your own instrument and plug it into another music software. So another program would be the host for my synthesizer. And that way, well, apart from moving to C++, I would have a GUI, which was like this. And that's only part of that, because this was an early screenshot. When I finished, there was like double the values you could change. So it was like quite a lot of things to map. And this was a little bit cleaner. Like you have classes now, and you could have like, like everything was encapsulated and everything was like there. You didn't have to see all the values out there. And I'm not going to subject you to the torture of listening to the sample song, but you can do it in your own home. So here comes the boring part. Like writing all that GUI part, you had to do all those horrible things, like casting to things like this is part of Cubase, Steinberg's values, whatever magical things they put in there. And that's only one of the parts. I'm just going to show you the whole thing. I was looking at that yesterday. I was like, did I really do that thing? Like, look at that. Look at that. Look at that. Keep looking at that. Because it keeps going. It keeps going. It goes and goes. And that's one of the parts, because there's another part, which is similar, and it goes forever. And I had to write all those kind of functions for formatting between things, because I wasn't obviously going to do the thing all the time. And it's slightly different for each value. So it's like, oh, jeez. When I finished this thing, I just did one song, and I just realized that, like, take it, do whatever you want with that, because I don't want to do anything else with this thing. But the most funny thing of this thing is that people use that. It's like, oh, Jesus Christ. And the thing is that it was in Linux. I was using Linux at that time because I was like, I don't like Windows, I don't like Mac, I don't like anything else other than like free software and stuff. And people build packages for Ubuntu and for Fedora. And even make cool songs. Like, did my synthesizer be able to do this kind of things? Like, it was like, wow, I didn't know that my software could do this thing. So it's the nice thing that I found when you do something and you just like instead of hiding it in your pocket and be ashamed of what you did, you just release it and people start using it and it's like, that's cool. I didn't know I could kind of be the vehicle for somebody else's creation. And it kind of makes me really proud of the whole process of going through all those parameters and stuff. It's like, it's worth it at the end in a way where. So then we had 2011. We got to audio in the browser. I mean, there have been some efforts before. We have Flash and the Adobe Make Some Noise initiative to get Adobe to get proper audio in the browser through Flash. But it was Flash. I mean, I was using Linux. I didn't want to use Flash in Linux, right? So I was like, I'm not going to do any audio in the browser until we have proper native audio support. So the first thing was the audio tag hacks, which was kind of really a good hack. Like you were feeding base64 wave data to the audio tag. So it was kind of glitchy and it had like hiccups from time to time. But it was the start. And then somebody contributed a piece of code to Firefox so they could do the same thing but in a native way. And it was pretty much the same thing that I was doing. I was just like having a buffer and a callback and feeding with audio data. In the meantime, Chrome did web audio and they did their huge thing with, what happened here? Okay, something going weird. Maybe I can do this. Hey, good, HTML. So there was this fight, web audio versus audio data, and web audio won. And why? Because audio data was just a buffer, so it was fine for people like me that were just experimenting and doing small things, but web audio is modular, is and was, because it's the one which we are currently using. And the thing is that it has many useful ready-made units, so you can have reverb units, filters, many things that otherwise you have to implement, and I did that for my synthesizer, and that's very tedious because you have to go to pages and look for fragments of code of things you never will ever understand unless you're a graduate in physics or something. I was like, I don't know, it kind of sounds like I want, but I'm not sure still how it works. So it was kind of, and also it has 3D support. So if you go into games, which is a huge part of converting people to web, you need to have 3D support. So it became the standard, and not only became the standard, but it's also implemented in Firefox Tools, so it's double standard. And it's even in iOS, which is like, I mean, it's something that takes time to move. And it's also in Chrome Mobile, and it's in the works for Firefox Random, so it's very exciting. It's absolutely exciting. But that's not the best thing. The best thing is that we also have web components, which is like another super exciting part, but what the fuck is a component? It's like, okay, so you go to dictionaries like constituent, product, element, and ingredient. Oh, fine, sure. Scripts are components. Resistors and components, and even a doorbell could be a component. It's just something that works, and you don't need to know how it works. I mean, is there, and if you know how to operate that, it will work, unless you kind of disassemble that to see what's inside. But you generally don't do that with components. So with web components, you have, you can create your custom elements, like you've got strong, or you have HRs, or whatever other tags. You can add your own, and you don't have to wait for the W3C to create your next new big tag. You can do it today, and it will work in your browser. And you will look at the source code, and it will be there with the rest of all known tags. So you have your custom behavior, custom appearance, and then encapsulation, and reusability, which is really interesting. And I was like, So I was waiting in the airport. I was bored. And I was like, so this Cascadia thing, they are opening for proposals. Maybe I could do something. I have no idea what. But I want to go to Vancouver. Yeah, because I was in Toronto airport. I was like, Canada is a very nice country. I want to go back. I had to think of something. So I was like, I had been working in Toronto Mozilla office for that week. And I was like, I want to do something. I need to use what I learned this week. And it was about web components. And I was like, you know, what's what I like? What music? So obviously, why not audio components? So it made sense. Like web audio is modular and web components are modular, so why not? So I went for audio tags, which is how, because there was some other project already called audio components or something like that. So I don't want to ruin their SOE or whatever. So here's the catchline: custom audio with less boilerplate, which I guess could be working as a selling point. So I think I could go through the whole thing of how it's written, but it's going to kill you all. It's not that there's too much code, but it's boring to look at things without knowing why. I understand better things if I have a purpose. So I thought, well, let's build a simple synthesizer. So, yeah. So the audio, I'm just going to go step by step and show you things so that you understand how this works, even if you don't know anything about audio, hopefully, which is another of my goals. So the audio context, if you've done any Canvas or WebGL programming, you know you get the context first, or you get the canvas first, then you get the context for the canvas. And that's the one that gives you the functions and all the methods that you can use for actually doing things. So it's like the painter's box. That's where the tools are. So in audio, it's the same thing. You need to have a context, and that's where things happen. So in my simplification, that's how you get the context. That's it, nothing else. But obviously, you need to make some noise, otherwise it's kind of boring, like you having a context idling and doing nothing. So the most basic unit that you can use for making noise or just getting some sort of output in web audio is using an oscillator. And an oscillator just generates periodic waveforms like whoa, whoa, whoa. And it's got a frequency. So go back. So it's got a frequency, and depending on the frequency, you get different pitches. Like a high frequency is like very high pitch, and a lower frequency is a very low pitch. Like drums are very low pitched. For example, a violin is a high pitch. I'm just assuming that no one knows anything about anything. So sorry if I'm going too low, but yeah, it's good to know what the differences are. So in my simplification again, this is how you would build this thing. And I'm going to show you an example, because now we have something that could actually sound. And that's it, actually. I mean, just see the source, and here's the interesting part. And I'm going to need to, because some wave types are very harsh, like this one, and that. So yeah, that's the issue with doing these kind of things that are very basic. So that's the oscillator, and with this thing you can build many things, but right now it's very raw, so we need to combine it with more things. So we need to mix things, which is one of the first things you need. So the mixer is going to add the output of its children into a single output. What it does is it goes through the DOM children. So I mean, I'm talking about elements all the time. I'm not talking about JavaScript objects in the ether. I'm talking about things that are in the HTML page. So it's going to go through all its children and sum the output of the waveforms and just feed them into a final thing. So if you have this structure, you have this audio context here, which is like holding the whole thing together. And then the mixer, which is like embracing the oscillators. And then you've got each one in a different frequency. You see, yeah, I'm using attributes because it's very declarative. I'm not sending parameters or anything. You can describe the whole synthesizer with just HTML, which is kind of, I find it quite interesting. I hope this doesn't blow up. Hey. Okay. So those are playing two notes at the same time. What's this thing doing? Mystery. And again, I mean, it's just adding the two of them. But you can't really see much of that because we need a chain to feed the output of one thing to the input of the other. And that way we can analyze what's going on through the pipes. So with that, we can have oscilloscopes, which are fancy. So what we do here is instead of going through the children and just adding them, we are just connecting one to the other. So this oscillator output is connected to this oscilloscope, and the output of the oscilloscope goes to the output of the chain, which goes fed to the context finally. This example is way more visual and will make more sense, like this. This is what is getting output, and probably not wanted to kill your ears. See how it's changing. So, this is basic, but I think it's quite educative to be able to change things in the browser and see how the changes affect without having to invest in, I don't know, understanding everything and downloading pure data or any of those programs for doing audio manipulation. And then the JusticeCop is just what you saw. I'm not going to put that again. It's just a canvas. It doesn't have. I'm using for all these things. I'm using parts of Web3 or of the Web Audio API. I'm just wrapping them and using them as it were. I'm not doing anything magical. So it's the nice thing that it's modular. I can use that like easily. It's not something that you have to unwrap and complicate yourself. So yeah, I'm confused to use this thing. So yeah, I've said that thing. And you've noticed that the output is very harsh sometimes, so we need to filter. And that's why I was explaining the frequencies and everything. Like what filters do is modifying the input, and it allows some frequencies to pass. I mean, it depends on the filter. You have filters which are like low pass, and they will only allow low frequencies to go through. And you have high pass, like I just want to have the high things going through. You can have band pass, like only those ones, or filters that reject specific bands. So there's a lot of science behind that. And Web doesn't implement all the possible filters, but it allows you to implement custom ones if you want, which I haven't. But in this case, I'm just adding it to the same chain than before. So you have the oscillator, and you've got the filter, and I said use a low pass thing, so we kind of smoothen the whole thing. Basically, when you say I want a low pass filter, it's kind of equivalent to just covering your ears, because the high frequencies travel through the air, and the low frequencies travel through pretty much the body. I mean, you feel the low frequencies. So if you cover your ears, you still feel the frequencies, but you don't hear the higher. So it's pretty much like a dumping the sound. So it's like filtering the higher, and it just goes very like fatter in a way. See, it's normally the square wave is way more like square, and because I tell you there's a lot of physics to this thing, but the square wave has a lot of harmonics, and the more harmonics something has, more square it is, because it's the purest wave possible. And because we are cutting through some of the frequencies, we are reducing harmonics, and we are like smoothing the things. So that's why it doesn't sound as harsh to the ears as it normally does. So with this thing, we can build many things. I mean, it's pretty amazing that you can just, with a couple of components, you can build something that you could maybe build with an Arduino or something like that. So I decided, like, what could I use that would be complex enough to deserve the categorization of reminiscence. So 2 oscillators, so we have a fat bass, like who doesn't like a fat bass, right? I live in London, so there's like quite a culture of raving and dumb, that thing. So we also need a filter, because the best part of having a synthesizer is filtering and doing like sweeps, like whoa, 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 whoa. So you need that thing, and that's all you need, actually. So you just have this mixer for summing the output of 2 oscillators, and you feed the mixer, because we are in a chain, we feed the mixer to the filter, because this is the chain, this is the output, and we are done. That's the basic structure of the sense. And I think it's here. Okay, this is more or less equivalent with raw wave audio. You have to create the mixer gain first, and then you create the oscillators 1 and 2, and connect them to the mixer gain, like compared to this one. Like, this is mixer gain. I mean, you need a node to connect things to. I'm doing that internally, so you don't have to. But if you don't do that, you need to do it manually. So you have to create the gain, output, the oscillators, which is what we're doing. Hey, where do we go? Okay. And then you have to create the filter, and you have to configure it, which is not done here for the sake of simplicity. And then you finally connect this thing. And the issue with this thing is like the output is filtered. And if you look at this thing, it's like, what is this thing doing? You have to stop and say, like, if you connect this thing here, and then this thing here, and then this, maybe this is going through this thing, and maybe that. Whereas if you see this structure, it's more hierarchical, and I think it's a bit more easy to understand. I don't know about you, but it's got a little more of a structure than just plain lines of things, connecting things in JavaScript. So we've got this thing that we built, but we need to tell it to start. So we need to redefine this function. That's why I said that there are things here and here that I'm not showing you, but all the tags have a start, stop, not on and not off method that we overwrite or overload if we want to do something special. So there's kind of a little bit of setup already done for you. So when you want to start the synthesizer, the first thing you want to make sure is that you don't destroy people's ears. So that's done by ensuring that you don't go over the possible values. So you just, there are many methods. You could use a compressor, but let's do this thing simply. So you just say, like, if basic maths, like if you have two things and you divide by 2, what's the maximum you get? 1. So this is the same thing. Like all the outputs can only go from 1 to -1. So if you divide by the number of oscillators, you can never go over or under -1. So that's the thing I'm doing here, like getting the gain for all the oscillators. And then I multiply that here. And then I just start them. Like this is another unit that we were using before. So because all of them have this method, and this kind of gets propagated, this start to this one. Oh. And the stop is pretty simple. It's pretty much the same. Like for all my oscillators, stop all of them. And it's also interesting to see the when thing, because WebAudio works it kind of sets callbacks or timeouts more exactly. So you need to tell it when to stop, so you can program the thing. So if you say 0, it will try to stop immediately. If you say more than 0, it will try to stop after when. So you need to use this thing as well, unless you want to play only on real time. And then you also need to set the frequency. Like WebAudio only has the concept of start and stop, but it doesn't have the concept of not on that all other music programs have. So I had this kind of discrepancy mentally. I was like, do I do everything at the same time or do I do separately? And I did it together in another project. I was like, I'm going to try to separate this thing now. So that way I can just send a note if I want and keep it and stop and start it, and it will still try to play the same note. So it will change the frequency. And another interesting thing I'm doing is I'm using these MIDI utils. MIDI is like a standard for musical instruments, and I'm just using this thing because that way, if I want to jam, imagine how amazing it could be. Like, say you've got a MIDI instrument and you want to jam with someone else playing in a browser. By using this thing, you're using the same note numbers and the same frequencies, and you're always going to be playing in tune, which is really good. So with maths and stuff, you can say that plus 12 just increases 1 octave. So the two oscillators are going to be like playing 1 octave and the other another octave. So it will make like a thicker sound, and that's pretty good for basics. Otherwise, it's like, this doesn't have any substance. So for triggering notes, what about a keyboard, right? Like, that's the natural thing. So I built another component, which was a keyboard. And I can also have this attribute thing, like 2 or 1. And not much more than that, because the physical keyboards don't have much more than that. But we could go farther if we had more keys. And this keyboard just dispatches. I mean, you can. I'll show you later. But you can press keys in the keyboard, or you can touch with the mouse, or any other touch event. So it will always dispatch events. And I was experimenting more, and I just custom DOM events, which is why I'm getting this e.detail.index. It's kind of strange. I'm not sure if it's the best thing. In the past, I used my own custom elements, but I'm not sure. I like trying things and seeing how bad or how good they are compared to my existing code. So this is like, let's try all the new things and see how much it breaks. So I'm just creating those elements, those events inside the keyboard and propagating them. And this is the listeners you use. Like, it's got not on and node off. It's not very interesting. And normally, you should be listening to which node has been stopped if you have a multi-voice instrument, because you can stop and start different voices. But in this case, this is a simple one. I didn't want to overcomplicate the thing, so I was like, when we receive node off, we just stop the whole thing. Demos is the best part, I guess. Hey, there we go. It's 2 hits. Okay, so that's my keyboard. See, I can kind of go through, and I can also play with it. And this thing is, the way it works is this thing triggers events, which I'm listening in the code of this thing, and then whatever I get, I send it to the synthesizer, which is this thing. And I'm connecting this with a chain to the oscilloscope, so I can see what's going on. And then I can try to... So initially it's set to all pass, like nothing's getting filtered, but you could try to make it low pass. I mean, it's just a demo, right? Yeah, the issue I'm having right now is because I usually have like an external keyboard connected to this thing, so having this thing losing the focus here, if I lose the focus here, for changing things here, and then I had to go back here. I need to devise a way of improving that thing. But so far, I think it's pretty neat to be able to just create an instance of this keyboard and send events to things. Like, you don't need to program your own custom whatever. I mean, you just include the thing and just use it. I'm going to use it all the time. Yeah, and you need to become a rock star, right? So there we go. So now we've got an instrument, and we are rock stars. So obviously, rock stars needs to look cool. And Angelina gave me this thing, which is supposed to look cool. Does it look cool? I hope it does, because I don't see nothing now. So rock stars, they have signature guitars. I don't know if you've seen them, but like Ibanez or whatever, they have their custom design guitars, and I kind of fell in face to that thing. I said, well, I want something like that. So we have CSS, right? So we can change things. It's not the same, but it's the poor man's equivalent. So I'm going to try this humble synthesizer into a fiery, hot object of desire, hopefully. So that's why this thing kind of betrayed me. And I tried to make it as tacky as I could. How does it work? Like, it's got leopard, and it's pretty hard to find these textures at 3 a.m. when you're kind of like, what am I doing here? Yeah, so that was basically it, I think. Let me remove this thing. I can't see anything. Where did you use this thing? Yeah. So to wrap up, we've had this other task where you to experiment with audio without drowning in details. Like, you can have fun without messing too much with code and funny sunglasses. But this is just a prototype. So I'm kind of inviting you to fork the project and break it, which is something that is very easy to do because there are lots of things that will fail. I'm not going to tell you. I'll just let you find it out. It's there. I think it's not the whole thing is there because I forgot to commit something before coming here. But it will be there. And I actually realized that I wanted to show you more things, but I forgot to add them. And when I came here, I forgot about adding them again. So I will probably update the slides, which are kind of almost there. I mean, they're missing some things. I mean, it's all like half-baked. I mean, I'm jet lagged, so deal with that. So thank you for going through this thing.